Hello everyone, welcome back. So in this video we are going to understand this Leetcode problem number 1622. It's a fancy sequence problem where you have given couple of things. As you can see in the example, right, we have given a class fancy where these are the methods: fancy, append all, uh, append, multiply all, get index, right? So these are the functions we have given, and we have to implement this a fancy class, right? And we let me show you the class actually. So as you can see here, we have given this class fancy and we have to implement these methods. So let's talk about this method, what the method we have given, what the class we have to implement, and what the features we have given in each of the method. So let's talk about the Leetcode problem number 1622. It's a fancy sequence problem, and basically this question is based on the lazy update and the concept of mode arithmetics, right? So we'll try to understand what the question is saying. That very first, let's go with the problem. So problem it is saying that we need to build a data structure that is called fancy. It's a class as a data structure, right? And that support these operations. So let's suppose we have a fancy as a data structure. So what it should contain, these are the operation it should have there. Very first, append means if we want to add a number to the sequence, we will call this method that is called append. We have add all, so we have to pass the what increment we want for the every number. So every number that we have given, we have to do the increment. If you want to multiply with the m, right, to all, so we have to multiply every element by m, then we will call this function. Then we have get index. If you want our a value at a given index, so it is called get index method. Okay, so all these operations that we will perform, right, will get some answer. So all the answer must be returned to the mod 10 to the power 9 plus 7. You also say t 9 7, we can say that, right? So you have to take the mod and you have to return it. Okay, I hope you understand what we need to do, what we are trying to do here, right? So if you have understood this problem, right, it's very simple. The fancy sequence is saying that, let's suppose, have you ever seen a problem where you must update thousands of number instantly without actually updating them, right? That is called lazy update. Okay, so that's exactly what happens in this problem that we are going to see, the fancy sequence. And in this problem we must support operations like we have discussed here, right? These operations. So append number, add to every number, multiply and retrieval values. So these functions should have in this fancy class. But there is a catch. The sequence can grow up to 10,000, not 10,000, 1 lakh we can say, right? Maximum. So 10, so let's suppose 100k we have element, right? 100k elements we have, right? Means 1 lakh elements we have. So sequence can grow up to 1 lakh elements, we can say that, right? We can say 1 lakh element. And operation can go 1 lakh also, means like this. Okay, means operation can go also 1 lakh and elements can also go 1 lakh. So we understand this sequence, right? This is growable till 1 lakh elements, 1 lakh operations. So if we update every element each time, right, because how many elements are there? 1 lakh elements are there. If 1 lakh elements are there, if you want to update every element, the program will definitely go for the timeout, right? Because it takes more time, right? Because see, 1 lakh element is there and you will perform all these operations. It means what will happen? It will go for the timeout, right? So how do we solve this problem? So let's try to go with the understanding. The answer is very clear. We have to do the math, right? And there will the concept we have is this is called the lazy update, lazy transformation, we can also say. We'll use the modular arithmetic later. So let's break down this problem in very simple terms so you will understand clearly. Okay, let me show you. So let's go with an example, right? So we need a data structure that is called fancy and it supports 4 operations. Let's call the operation 1. So very first operation 1 we have, where we have to do what? Append. So if we append some value, so this value means we have to add a number to the sequence, right? So if we'll say, okay, in place of the append this value, if we'll take what? if we'll take 2, right? So what is the sequence now? So we'll say, okay, here sequence is, let's call 2 we have. Okay, then let's suppose we have operation 2. Okay, so this time let's suppose we want to add all, right? In add all, what we want? Increment. Right? If we want to add a number to every element, let's call here, we'll add a element. That element is nothing but, let's suppose we'll keep 3. Okay, it means what? We want to increment our sequence by how much? By 3. So what is sequence now? So sequence should be 5 now, right? Correct. Previously it was 2. So 2 plus 3 is how much? 5. Correct. So we got the sequence like this. Now let's suppose we have an operation, right? So this operation, let's call, we want a multiply, right? Multiply all, we can say like this. It was given here, we have to pass m. Okay, means we want to multiply every element by this m. So if I'll take m in place of something else, right? Let's call, we'll take 2, right? It means what? This is, we have 5. So 5 into 2 is what? We will get 10. So we'll say the sequence will have is 10. Understanding or not? Means every element in the sequence will multiply by these 2. Let's talk about, so this is operation 3 and this is operation 4. Okay, so let's talk understanding how the operation we are performing, right? So let's suppose we have get index function we have, and we have I. Okay, here at this time we want to return some value, right? At index and index here. So index, if you take anything, the index 1 we can take, you will get the value, right? Means the value at index. So this I can be anything. If I pass 0, we'll return this one. So no need to write. You understand, right? So we have seen that if we'll append some value, we'll get the sequence. In step 2, yeah, operation 2, we will add all, we'll get the sequence. Then we'll, let's suppose we'll append again. It means what? Let's suppose here we will append one more element. So what will happen? 5 and 7. If you want to append one more, 7 we have added here, right? So we can do that, right? Then let's suppose we'll multiply. So it means what will happen? 5 and 5 become 10. So we'll say 5 become 10. Now after 5 and 7 become 14, we can say, right? Like this value will happen. Like this, you have to keep doing that, and whatever the index you want, index 0 we want, index 1 we want. If you return index 0 here, 0, you will get 10. If you write 1, you will get 14. Like that, if you have to keep going, and you will get the some value, right? Means here we have 1 lakh elements can grow. This data structure can grow 1 lakh, and 1 lakh operation can be happen, right? That is why the approach that we are going to perform will fail. Means we can say why the brute force will fail. If actually we update every element, right? Let's suppose 1 lakh elements we have. So if we are going for updating every element, then we call what? We will call either add all, or we can call multiply all. These two functions we have given, right? So these, each operation will cost, each operation, I'm talking about this operation and this operation. So these two operation, let's suppose it is taking O of n, and it is also taking O of n, because n is 1 lakh, right? 1 lakh elements, and this one operation will take O of n times, right? But a problem actually allows how many operations? These type of operations. This type of operation is 1 lakh operations, right? These are the 1 lakh operations, and these are 1 lakh elements. Understand? It means, just think that if we have something like 1 lakh operations and 1 lakh elements, if we'll multiply this, right, how much we will get it? We'll get it approximately 10 to power 10 operations total, right? And definitely, if such a number will happen, I'm talking about what will happen? 10 to the power 10, we just say operations. Understand? So it will get how much? Definitely it will cause, right? And it will give you TLE, time limit exceed. So we need a smarter approach, right? So let's talk about the smarter approach, guys. Okay. The very first thing that instead of operating every elements, we track a global transformation. Okay. So we will maintain two variables. Okay. We'll take two variables, that is multiply and add. So multiply is a global multiplier, we can say multiplier, global multiplier, and add is a global addition. I hope you are understanding, right? So these value of any elements become, let's suppose we have some value, we want some value, so there will be some original value will be there, right? We will multiply and we will add. So we'll update the value like this. Okay, this means we don't update the array, we only update these two variables. Okay, and our work will happen simultaneously, right? It means these two variables, let's suppose we'll start with multiply, will start with 1, and this value will start at from 0, right? So let's suppose very first comes add all, and we'll say 3. Okay, then what will happen means we want to update add from 0 to 3. So this will happen. So formula becomes, right, formula becomes like this. We have value, right, the value we can say, and some value will we have x is a value, we'll just say plus 3, like this. I'm talking about understanding. Let's suppose further we want multiply all, right? Here we will pass two things, right, two. So when we'll multiply, right, obviously the multiply is nothing but multiply into 2, and add become what? Add into 2, correct? So here what we will get, we'll get some value. Multiply is initially is 1, we'll get 2. Add is some, already we have 3, now it become, we have to multiply, so it becomes 6. Like that our value will, formula will get changed. Now the value is what? We'll get x into 2 plus 6, right? Like that we have keep going and we'll find the value. So think of like we have already some value, right? Let's suppose if we have already some value, let's suppose the stored value is 2 and 7 we have, right? If we want the transformation layer, means the value, right? So value, how we'll get the stored value? Stored into multiply plus add, correct? So what is the current transformation will happen? So currently we have 2 and 7 we have, right? So multiply, let's suppose is 2 and this add is 6, means 2 will become is 2 into 2 plus 6 is nothing but 10. Then we have 7, 7 become what? 7 into 2 plus 6 is equal to 20. So we have to compute the value only when needed, right? So this is a smarter trick that we can use, right? Similarly, for the append trick, right? Let's call the append trick. How will you append, right? So if we append a number after the transformation, right, we must store the value in the reverse form, right? How? So we'll say, okay, stored is nothing but what is the value minus add, and you will just divide by the multiply. But if we have division in the modular, it requires the modular inverse, right? It means we can say the stored, we can say is, we can say val minus add, and you have to take the modular inverse. Mod inverse function you will apply, and you will pass the mod. So this will give you the value very consistently. Okay, let's go to the code, you will understand. I hope till that you will we have already understood. If you have any doubt, you can ping me in the comment box. Okay, let's go to the board and we'll understand. Editor, yeah. So let's understand uh, the problem. Okay, the very first thing is we have defined these values, like the long array we have to define, as we discussed. The multiply we have to define, and the add we have to define as a global variable, and the mod 10 to power 9 plus 7 we have to define. Then we'll very first to the constructor we'll initialize the array list, right? So we can keep adding the value in the sequence. So the array is nothing but for the sequence. Then we'll take the append formula that we have discussed. We'll take the inverse in the another case, and we'll keep appending the value. Then we have the add, then we have multiply. So multiply, when we'll do the multiply, we can have to find the multiply and the add also. So we have to uh, find the value, right, as you can see here. Then we have a get index function, where you have to find the index. You just need to pass to the array index, right? It will return the value. And to take the mod, you have to do the modulation. Similarly, for the mod inverse, you need to do the mod inverse. This is the mod function inverse that we know. And for the power, right, we have to take the power of this. So in that case, because internally it calls this function, where you need to pass a and b, and you have to calculate the inverse function. Okay, so this is what we have in this video. In case if you are struggling with anything, please ping me in the comment box, and we'll understand the question. Okay, so that's all in this video, guys. In case you are learning data structure and are preparing for the FANG preparation and the product based company, you can join my online classes. And for that, you can ping me in my WhatsApp channel, and you can join our WhatsApp group also. So that's all I have in this video. I'll see you in the next one.
Thank you guys. Thank you for watching this video. If you found this video helpful, please like, subscribe, and let us know what you want to learn next in the comment below. And thank you for watching this video.